Hi everyone, in this video I'll briefly walk through my M5 practice project. My project is a customer churn classification task using the customer churn dataset. My goal was not only to build a strong predictive model, but also to evaluate it using responsible AI principles, especially fairness, transparency, and interpretability. I started with the basic data cleaning and overview. After converting total charges to numeric, the final dataset had no missing values. The target variable was moderately imbalanced, with about 73.5% non-churn and 26.5% churn. So I evaluate the models using multiple metrics, including accuracy, precision, recall, F1, and ROCAUC. I then compared four models, including logistic regression, random forest, XGBoost, and gradient boosting. Based on cross-validation and validation performance, I selected gradient boosting as the final model. On the test set, it achieved accuracy of 0.8062, precision of 0.6735, recall of 0.82, F1 of 0.5895, and ROC and AUC of 0.8434. So overall, the model performed well, although recall for churn customers was still moderate. The most important part of this project was the responsible AI analysis. I specifically evaluated fairness across two group variables, gender and senior citizen. For gender, the model looked relatively fair. The demographic parity difference was about 0.003, and the equalized odds difference was about 0.017. So the group differences were very small. However, for senior citizens, the disparity was much larger. The demographic parity difference was about 0.204, and the equalized odds difference was about 0.152. This told me that the model behaved less fairly for senior versus non-senior customers. So the main fairness concern in this notebook was not gender, but age-related group disparity. To address this issue, I built a challenger model without the sensitive features, gender and senior citizen. This was my fairness mitigation step. The result was meaningful. The Challenger model did not lose performance. In fact, its accuracy increased slightly to 0.8084, and its F1 also improved slightly. At the same time, fairness for the senior group improved because both demographic parity difference and equalized odds difference became smaller. So this gave me a better fairness performance trade-off, which is an important responsible AI outcome. For interpretability, I use multiple tools so that model would be transparent at both global and local levels. First, I used feature importance and SHAP summary plots for global explanation. This showed that important drivers including cat streaming, movies, tenure, senior citizen, paperless billing, and several service-related features. SHAP was especially useful because it showed not just which variables mattered, but also how they influenced predictions. For example, high monthly charges generally pushed predictions more toward churn. Then, for local explanation, I used both SHAP and LIME. on one customer. Both methods gave a similar story, which increases confidence in the explanation. Some features pushed that customer's prediction toward churn, while others pushed it back toward non-churn. This is important for ethical decision making because it helps stakeholders understand why a customer is being flagged instead of treating the model like a black box. I also included partial dependence plots to show how important variables such as tenure and monthly charges affect the model on average. In addition, I used a counterfactual or what if explanation. For the selected customer, the original churn probability was about 0.208, and the best what if scenario reduced it about 0.136. This made the model more actionable because it showed which kinds of business changes, especially contract-related and support-related changes, may reduce churn risk. For an ethical perspective, I noted that historical churn data may reflect existing differences across customer groups, so fairness adopting is necessary. A model like this should support decision making, not replace human judge completely. For deduction readiness, I would add data quality checks, fairness monitoring, drift detection, explanation logging, and regular retraining. To conclude, this project shows that a good model is not only about predictive accuracy, a responsive model should also be fair across groups, more interpretable, and more useful for ethical and practical decision making. In my case, the Challenger model without sensitive feature gave the best overall balance between performance and fairness, and the interpretability tools helped make the model more transparent and actionable. Thank you.